Hi, good afternoon, everyone. Thanks for joining us this afternoon. Hopefully, you'll find this interesting. It's the BDA's approach to site categorisation, um, and I intend to run through what it is, explain how the best practice is to follow the guidance, and how Socotec deliver this. What do we have in place to ensure we protect our workforce and the environment? So hopefully everybody can see my screen in the background. If you can't see us or any issues, please let me know at any time. So a bit more information about myself before I start. The idea of this is 45 minutes presentation, and I'll allow 15 minutes of questions and answers at the end. So please feel free, any queries you have, always happy to help them where I can. If I can't answer it by the end of the day, I will get back to you if you can leave your details, and I'll run through these slides very short. A bit more about myself. So I'm currently the ground investigation geomental lead with the ground investigation team at Socotec, based in Northwest. My background is in contaminated land and human health control water risk assessment, having around about over 20 years of experience in this field. I began my consultancy career at Socotec, and I've gone full circle through various other consultancies and experiences throughout my career. Ultimately, I've come back in this role prior to being a project manager, also senior engineer with Socotec, so I have a full exposure to everything that we have in the field. So moving on. Okay, so why we're all today. So why do we have the BDA site category approach? Why do we have to assess the risk to our from our activities to our workers? So when you see this slide, it's a typical drill rig, common occurrence every day that we do in our activities in our field line of work. What is beneath there? There could be anything, but anything that our workers are exposed to. And the approach is to provide a process, a structured risk assessment process to identify what might be in the ground which may pose a risk to our workers. So could it be asbestos? We all know the impacts of asbestos to human health. There could be volatile vapors from petroleum products which have been disposed of or leaked into the ground over time. Hydrocarbons from storage of fuels, explosive situations such as ground gases, naturally occurring or from landfill which may ignite, explode, or actually are flammable, and also some asphyxiants in confined spaces. And also maybe microbiological. People may be aware of anthrax associated with tanneries, buried animals which may be in the ground. Spores may be dormant until we open the ground and our workers inhale them. And then for contacting anthrax or some other virus which may impact their health. So it could be anything, and that's why the importance of why we adhere to this process and the importance of having the BDA's approach and new guidance that we follow. So occupational risk is real in industry and construction. 5,000 asbestos-related deaths per year. This is not specifically to ground investigation workers or workforce associated with the industry, lab testing, etc. But it is a risk that our workforce can be exposed to, where there's asbestos present in the ground, the asbestos in our samples, and it's sent to the labs, and they inhale the fibres. So you can see that the figures are there for us to see. We don't want to be a statistic. We don't want any of our workforce to be one of those statistics, albeit maybe lower. We're dealing with wet ground. We've got a duty of care to our workforce and people that we employ in the line of ground investigation to protect them from these illnesses and to live a long and fulfilled life. As you can see, there's still a peak and we're slowly declining from occupational exposure risk in the field of construction industry. And it's slowly declining, but unfortunately for us in the ground investigation industry, there's a lot of materials have been backfilled into the grounds across the areas we work and across the sites, which may still contain asbestos from previous developments, from previous disposal. So, you know, the risk, although the stats show it's a decline, the risk is still there for us ground investigation workers involved in this line of work. So just the impacts of occupational exposure, just to bring it home more than anything. So, these are just things you see in the news from time to time. Grandfather's chest infection was actually asbestos related, cancer from being smothered in dust 40 years ago, loving daughter dying after cutting asbestos dad. So we all hear about the story about a girl. I've been told this by many asbestos awareness trainings. Come home, she used to rub her dad's hair to see the snowstorm. He was an asbestos worker spraying asbestos coatings. She inhaled asbestos every day, seeing the snowstorm, and subsequently contacted asbestosis through that exposure. So it's stuff that, it's not just us as in the workforce that may be exposed to things in the ground. We may take it home to our loved ones, our family, our friends, which we try and avoid. We don't try and avoid that. We will avoid that, and that's one thing we want to prevent by following this guidance and how we do it at Socotec. So occupational risk in ground investigation, as well as asbestos, various contaminants you can see on the screen. We may come in contact with metals, heavy metals in ground. We all know the impacts of lead, how it has in our bloodstream. Volatile vapors are carcinogenic, particularly some chlorinated solvents, TT commonly used as a degreasing agent. All these common things we may find in the ground during our line of work. So in ground investigation, there's two types. There's mainly two types of site we investigate. We greenfield, the ones we love, nice green fields, easy access, ground conditions predominantly similar across. There's been no change to the ground conditions over time, and these are the land that's not been previously developed. Generally, what would be a green site or a low risk site. And there's brownfield sites that have been previously developed, manufacturing, buildings, houses, any land which has been previously developed on is brownfield. It's predominantly where the higher risk for us in ground investigation occurs in this area. But, out of land types described, where do you think we can encounter land contamination? I'll leave it out there. It could be all, the risk is reduced across all these sites, but we don't know until we find out more information about these sites. And that's what I hopefully want to demonstrate today. So the contaminant linkage is some definitions if you're not aware of what a contaminant linkage is, and it's how it's known as a source pathway receptor scenario. It's how a contaminant can enter a person or environment and impact it. So a source is a hazard. You need a source of contamination for a hazard to occur. You need a way of which it can somebody can be exposed to, inhaled, or contact with that hazard. I need a receptor, something that can be adversely affected by a pollutant, human health, the environment, the areas we commonly work in. And I'll touch on it later, but it's not just us, the workforce, we can impact. It's those people around us, people at home, but also third parties, members of the public, people walking by our sites, where we may release something which may impact them. So land can become affected in many ways through historical land use, these brownfield sites, and also the greenfield sites. For what we know, there may be changes to those sites over time. So pollution incidents, mine workings, contaminant migrations, spills, flooding can transport contaminants across the surface. It can transport laterally in the groundwater. So if we're drilling or investigating the site where there's contaminants in groundwater, it may not actually be in the soil, it could be in the groundwater that we're exposed to something. There's naturally high levels of substances, like where I live in North Wales, we have a lot of natural lead deposits in the thousands up in the villages around these lead mines. So historical land use can affect the ground. It's historical. Sometimes there's not many records to document these. One thing I like to point is contaminants in the ground have no warning signs attached. If these were products the products have been spilled released to ground, were on a shelf in a container in a manufacturing plant, they'll have hazard warning signs allocated to them. The things we see in the ground don't have these attached. So how do we know what is the risks associated with those in the ground? And of course, we have a duty of care under the COSH regulations. Contamination is one of them as a substance hazardous to health that we have to protect our workforce from. So we need to prevent exposure, reduce, control. We don't have direct COSH assessments for them for contaminated land, where we don't know what materials it is in the ground that we may encounter. But by following the BDA's guidance and approach to understanding the site and using that information in our risk assessments to mitigate the risk, we will be adhering to the COSH. So the journey of a contaminant from the ground. So as I mentioned, you need a source pathway receptor. Once the pathway, these are the pathways to absorption in humans. It could actually be in ecology as well. We could expose the natural wildlife to contaminants. So once contaminants enter the body, it's absorbed into the bloodstream. It's distributed through the body in the bloodstream. Once digested, the bioavailable fraction is metabolized and excreted. And it's various ways it can impact the body cells, which I'll explain. So the risk we face every day in ground investigation, potentially from, if we are investigating the worst case hazardous sites, um, where there's more likely to be harmful substances, these are what we can face. So the chemicals we come in contact may be toxic, they can pose as harmful, lethal dose of a chemical can cause fatality. Mutagenic can cause a change in our cells over time. Tetragenic, fetal development abnormalities, some PFAS is big news at the moment. And this research identified it possibly or was likely to cause that. Many carcinogens, most of us aware, benzoate, pyrene, one of the pHs in the ground, highly carcinogenic, benzene, toluene, ethyl benzene, all those additives to petrol, which may be in the ground that we may inhale. And in some cases, certain contaminants may cause respiratory sensitization, resulting in occupational asthma and restriction of the windpipe. So the risks we occur. So they can have chronic, acute, subchronic, things that can affect us over a long time or instantaneously over our life. And locally toxic, it can affect the organs, the target organs, such as when we inhale fibers into our lungs, can lead to asbestosis, or systemically toxic. Once in your body, it's transported to a different organ and it affects that organ. And I mentioned before, not just GI workers, we have to consider those who are outside our sites. We can transport contamination from our sites through odours, vapours, windblown dusts, mud trafficked into public areas, and also ground gases and vapours. Particularly from our drill flush, we can force in the ground if we're using incorrect flush, like an air mist in coal mine working areas. We can force gases through servicing which may be flammable, or vapours in petroleum areas. Also, we need to consider the environment through our activities with duty of care to protect the environment, also a legal requirement as well. So, for instance, if we're drilling through contamination, we may be drilling through aquetards, opening pathways for migration of contaminants down into the groundwater, causing it to be polluted. Surface runoff from our activities may run into a river, stream, surface water, causing pollution of that water body. From our activities, we have wastes, contaminated raisins, and drill and flush, which have duty of care to responsible for safe disposal. And also through in our activities, such as installing standpipes with response zones connecting to groundwater units, we may inadvertently allow a pathway between a dirty, contaminated groundwater body and a clean groundwater body, maybe a portable source, resulting in contamination impact of that. So there's a few cases where, if we hadn't carried out a bit of research, haven't understood the site before we went there, we didn't have the destiny information or the pre-construction information, we wouldn't have known what we're drilling into. And this is just to showcase, if we follow the process within the BDA guidance of, understanding and the site category, and looking at the risks that the site may present prior to mobilization to drill the site, we can see what, we have a good idea of what may be in the ground and mitigate that and protect our workforce from potential contaminants. So this is about the importance of outstanding the site. And this is an example where in 1921, you see on the left-hand side, some old brickworks, some clay extraction pits likely to be associated with those brickworks. Later on, we know through research, particularly from environmental search reports, it was landfilled over various decades, these infill pits, and then later it was built as a substation. We were instructed to investigate the substation at a later stage. If if we didn't have this information, we didn't have historical land use maps, the destiny that was presented to us, we wouldn't have known what might have been in the ground, and we may have inadvertently come across some contamination from those landfill sites, deposited industrial waste, because around in the 1920s to the 1950s, there's no regulations in waste disposal. So the likelihood was, there may have been something that, unregulated waste from industry that may have been in those areas, which we may come across and expose our workforce to. So it's an example of why we carry out desk studies and the importance of those prior to inform in the pre-planning stage what type of the site category the site has to be. So there's another example of another one as well. So it's residential house. Looking at it, you wouldn't expect to be anything on the ground. But if we carry out a desk study and find out, looked at historical plans, the actual development was built over the gasworks. So this key site case now. So this is the impacts of incorrect site category when it goes wrong, but not goes wrong. You don't fully understand the risk associated with the site. So here we received some PCI for a phase of works. Initially, a yellow site category. It was previous work done by contractors. So there was a lot of information out there that at the time we weren't party to. In hindsight, once we got the information, because it was a different landowner, we didn't have access to that information as part of the pre-mobilisation, pre-construction information. By looking at it, the evidence suggested it would have been red because they found contamination which wasn't revealed to us at an early stage. So during the investigation, we carried out the first shell we put into the ground. This came out of the ground full of hydrocarbons, strong odours, and we weren't prepared to obviously deal with it. So obviously we had to stop the site. It's a near miss because obviously we were shelling and we have to capture as we pull the shell. Despite having some initial protection measures in place, there's potential that we couldn't contain this material, these hydrocarbons. Also, the people have been exposed to whatever was in this material at the time. We know it's now. We know it's heavy range hydrocarbons, but at the time it could have been anything. There's delays. We had to reclassify stop works, make safe. There's a safety pause to reassess the risk. It delayed the program of drilling because we had to ensure we had everything in place prior to during the investigation to start work safely. So that's a knock-on effect of it. There's a near miss. We had potential exposure, but we had a delayed program because it wasn't quite right at the beginning. So moving on to the guidance, or what is it? So in 2008, the British Drilling Association recognised there was potential harm to ground investigating work in the environment, generally from increased brownfield development. Practices have changed. Legislation came into effect to protect workforce, Health Safe Work Act, and so on. And there's better understanding of acute and chronic risks, increased environmental awareness. So there had to be something in place to a guidance process or a strategy to help protect, to advise and help protect ground investigation in the workforce. So the one on the left there is 2008, guidance for safe and intrusive activities on contaminated or potentially contaminated land, bit of a tongue twister, and safe intrusive activities on land potentially impacted by contamination. And that's a more recent document. And I assisted on the working group involving the revision of the 2008 document representing the AGS, and it's in combination with Silk and the BDA who led the revision of that guidance document. So the BDA guidance, what is it? It's accepted as the adopted industry guidance for assessing the potential occupational risk to ground investigation workers, off-site land users, suppliers, and off-site support staff from those potential harmful substances in the ground to safeguard their health. So it's adopted guidance, industry accept this is the best approach or good practice to follow. So what's in it? These are just the main changes between the 2008 and the 2024 guidance. Obviously, updating legislation, predominantly introducing the CDM regulations as a key change there. A different stance and requirement for competence training qualifications. There's a different approach to managing health and safety and the environment on the site, and an even bigger focus now on the planning, pre-investigation planning, with actually preparation of desk studies and preparation of pre-construction information to provide to the GI contractors, or the GI contractors supports you in getting that information to ensure an accurate site category can be made. There are different processes in site management through changes in procedures, how we do things, and pollution prevention control activities that we can carry out. And there's ways of handling potentially contaminated mineral equipment. Hasn't changed, but it is more strategic and as a more of a process in place to make people more aware of the impacts of what samples and waste can have once it leaves the site. So on here, this is all this good stuff listed on here is associated with the latest BDA guidance. So the main importance of carrying out safe intrusive activities um, on potentially impacted land, potentially impacted by contamination. A bit of a tongue twister. So all these things here are covered in that document, from inductions, carrying out desk studies for your pre-construction information, requirement for your RAMs, use and training of PPE, RPE, insurances that need to be covered, fundamental health and safety planning. And so much advice and guidance in this document to ensure that if we follow it, we adhere to best practice to protect our workforce. So, in a nutshell, what's it describe? It correctly classifies the site risk category, helps us to do that, gives us a structured process to be able to understand what we need to do. Correctly assesses risk posed by potential hazardous substances. So it helps us to a structured way to what information is needed to be able to do that. What do we have to do in order to do that? Identify the appropriate health and safety environmental controls. So what do we need to put in place to reduce the risk? Obviously, we will have our RAMs, but identifying the hazards associated with the potential harmful substances in the ground. But what can we put in place to manage those risks, control those hazards? And the aim of this is to reduce risk to protect workers and the environment from their activities. Just some points to note is it doesn't replace any legislation. But HSE states that by following it should be doing enough to comply with the law. And also HSE accepts that guidance by industry bodies as a benchmark for good practice. So if we follow the guidance and the requirements and the advice given to it, you can be assured you're following good practice to ensure you're complying with legislation law to protect your workforce. So the BDA guidance safety process in the document, it gives you a chart of the whole process, starting from managing health and safety and environment through to the contract award and delivering a ground investigation. It's various steps to get there. The first part on the left is the information required to get to your BDA site categorisation. So you have a project specification requirements. There's a principal designer in place managing the health and safety aspects and the supply of the information. Usually at this stage, ideally a desk study for your project or your site is carried out to inform the health and safety plan for that project and also inform your risk assessments. Once all the information, pre-construction health and safety information has all been gathered together, principal designer ideally would produce a risk register to identify those hazards and provide that to the GDA site contractor with the appropriate BDA site category, which I'll explain what they are in a moment. On the right side, it's following site characterization. It's a contractual requirement, so tendering, ensuring insurance are in place, and so on, up to successful award. So what are the site categories? A lot of people working in the industry are already aware, but if not, it's based on very similar to a RAG system, but it's yellow instead of amber. So we have green, the low risk, yellow in intermediate risk, and red high risk. And these are based on the likelihood and potential for coming in contact with specific contaminants defined in the risk description. So green, for example, substances that have little potential to cause significant permanent harm to humans and the environment. Generally, there would be your greenfield undeveloped sites, but could also be uncontaminated sites with uncontaminated natural materials, brick, hardcore, inert materials that are unlikely to present a risk. Yellow, substances that are not sufficiently harmful, but they can have an impact and require protection to mitigate that impact on human health. So it might be a minor risk, might be a minor skin contact that can cause some sort of dermatitis, etc. That will probably be a yellow site. And examples would be waste with vital matter, general waste that doesn't have sufficient landfill gas in it, of course, non-toxic metals, and so on. But then you get your red sites. This is where substances that could subject persons to risk of death, injury, or impairment of health or pose a significant risk to environmental systems such as groundwater, etc. And it's those that those between yellow and red sites that that it is critical. The site category is right because obviously it's a difference between presenting a risk and not presenting a risk to the workforce, and also all those people in their jobs that handle those materials and samples thereafter. It could be in the store of where samples are stored. It could be in the lab. So, example, a geotechnical lab where there's no protection unless it's a specific red lab geared up to deal with any potential harmful substance in those materials. Such it could be dry sieving a made ground, for instance, with asbestos. If it wasn't identified as a risk to them, they could be, unaware something in as asbestos fibers in the soil and it's dry sieving it, creating dust in the air, they could be breathing that in. So that's why we do have the system, not just for the workforce, but those dealing materials thereafter. So every site must be categorised in ground investigation. We need to identify the risk from potential contaminants in the ground. And these are based on these definitions. They could be subjective, and it's usually qualitative unless we have information from previous phase investigation, contaminant data, previous reports, which identify the concentrations and types of contaminants in the ground. There's a variety of information sources that we utilize to identify the correct site category. Predominantly current land uses from walkovers, and I'll explain a few examples later, in historical land use practices from historical maps. So what information is needed to categorise the site in accordance with the guidance? And this is at Socotec what the stages that we see very regularly from our clients. Designers risk assessment site classification is provided. We receive pre-construction information from the principal designers. We carry out a desk study or a risk assessment carried out, or we can assist and conduct that for them to support that. And we have a GI specification which identifies the main risks associated with the works. All that information is provided as part of the pre-planning, usually at tender stage, and definitely at pre-mobilization. When categorizing a site, if you're involved as a designer at the designer stage, and us ourselves, if we're scoping our own works, the main question we ask, or we should be asking, is: do we have the correct level of information about the site to make an informed judgment to control and manage the risks from the potential hazardous substances in the ground? We have that duty of care to reduce risk to our workers and everybody who work on our projects. And the point is, once in the ground, there's no turning back. Exposure is instant and sometimes maybe acute. So, once you breathe in a face full of asbestos, that's in your lungs. There's no going back. So that's what we're trying to prevent. So robust PCI. So these are some main points. What do we need to do? So what's the aim of it? Helps identify the potential harmful substances in a nutshell. Helps us identify the correct mitigation and helps us protect the workers, public and environment. Simple as that. Three steps. If only it was that easy. One point you need to know, when we are categorising sites, it has to be precautionary. So if you hear something yellow, red, or yellow and green, and you're unsure whether or not there is a risk because you don't have enough information, higher the two categories usually should be taken as a precautionary measure, and it's based on likelihood, based on probability as well. So and all that, multiple lines of evidence to help you get to that stage. So what good looks like? So these are, so what good PCI pre-planning information needed in order to determine the correct site category. So what good looks like? Desk study report, review the site history, potential sources, review the site and environmental setting. So what's the geology we need for the site? What's the hydrogeological situation behind the site? Have there been any landfills on or near the site? Potential source of contamination, industry, land use around that area. Has a conceptual site model been developed for the site, understanding the sort of pathway receptor scenario? What are the hazards? What are the pathways? What are the receptors? Has a walkover been undertaken? Can we carry out a walkover? Can we identify what the current status of the site is? Any potential hazards? Also, it's good practice to do one as well, pre-mobilization, looking at access, constraints, where you're going to get rigs in, services, etc. So, it's very important to carry out a walkover study to understand your site. A specific PCI package information been provided. So sometimes a desk study cannot be provided, but the detail from a desk study has been gleaned out and provided in a PCI package of information, and some examples of that on the right side. And as a contractor, I've received a designer's risk assessment and as a risk register for the project being done. So all these are a good practice. All this is information to help us correctly categorize a site. So PCI in the center there, previously identified contamination. This is just an example provided to us from one of our clients in the past. So here, identified, from their package of information, May ground contains proven to contain asbestos, hydrocarbons, visual olfactory observations, and the types of contaminants. And there's a plan to show us where that contamination was identified as well. It just wasn't, oh, it's somewhere on this site. It was identified in a drawing. And on the right side there, there's a residual design health safety risk to construction and a designer's risk assessment. Identified here, for example, May ground possible contamination, May grounds anticipated, substantial thickness, there's risk of potential asbestos and chemical contamination. And straight away from that, and they've identified it as red because of the potential for asbestos fibres of unknown quantities, quantification across the site. All that's good information and really good practice. We can accurately categorise a site, and we know what we're dealing with. We come prepared. Our risk assessments and mitigation are in place, so there's no likelihood for any stoppage, any additional delays on programme. We have what we need to deal with the risk. Of course, those are sites with unforeseen contamination. There always is the case we find something we don't expect to. It's like the uncharted service in ground investigation you find from time to time on site. Buried, all sorts of things we find. There are unforeseen areas of contamination. It's just to minimise that potential risk as much as practically possible, reasonably possible. So moving on, in the guidance itself, it has sections or various sections discussing how and what needs to be considered. So for working on land potentially impacted by contamination, it's have this in place before. And at Socotec, it's what we have. We ensure all our staff are competent, they're trained in dealing with land contamination, red sites. We have processes in place, and we retain detailed records. So this bit is about training, knowledge, experience, skills, and attitude. And at Socotec, we ensure all our staff are prepared for dealing with red sites. We have a red site sample management plan, and we have also an approach, a procedure which people are trained on as well, dealing with red site working and how to deal with red site samples. Also, it's required your drilling contractors have to have the appropriate qualifications and experience in working on red sites as well, and it's detailed in that document what in the BDA guidance what's required. Also, you have to be aware that for certain sites, when we investigate certain sites of asbestos, it's just you may be from time to time require knowledge and understanding of asbestos, asbestos awareness, non-licensed workers training as well. That's very important when obviously it comes to, and also some people may have to require car soil training as well, depending on the nature of that site and the risk assessment taken to ensure you have the competent people in place to undertake risk assessments where you potentially have asbestos in the ground. Hazard identification desk studies. Now, a big part of the new guidance is getting it right, getting the pre-planning information right. I've already gone through it. I don't want to go on too much about doing instead of carrying out desk studies and getting pre-construction information, but it's very critical in understanding a site's history, land use, potential sources on that site before carrying out the investigation. And there's some good examples here. So this is one we prepared for a client, pre-mobilisation to inform the likely risks and site category. We carried an investigation, a desk study. We carried out a walkover, identified potential hazards on the site for prior to investigating, and also in some instances we created a conceptual site model. So that's for a different site, but that's something we were prepared to identify potential risks to the workforce prior to carrying out the work. We review historical mapping. So if you're undertaking desk studies, you'd be familiar with this whole process of reviewing historical map land use and understanding the historical use of a site. You can conduct research. So this is an example of a site we looked in the north, and an abstract from the Devil's Porridge Museum. This wasn't shown in historical land use maps, but it's actually an ammunition plant manufacturing that devil's porridge, which wasn't shown in any actual historical land use maps. It was removed, obviously, for secrecy purposes. But from our additional research, we identified this as well. So we could have inadvertently, if we thought there was just greenfield sites, without any further research, you could be investigating areas where there's previous manufacturing process, exposed to manufacturing process been there. And it's quite key as well, talk to people on site, talk to the land users, caretakers, if it's of the former sites, get site records from them, what's been used on the site before, has there been any spillages. And I've got a good example of a site where I was investigating potential risk from a laundry. We didn't at the time. Um, we had no understanding it was the dry cleaners. But the caretaker on the site told me as I was doing a walkover, oh yeah, we by the way, we spilt a load of dry cleaning agent here once before and it ran down the hill. And so on. So that gave us a good idea that obviously we have a perchlorine ethylene contamination in that area of the site straight away because of spillage that was taught to me for anecdotal source. You can't believe everything you're told, but it gave a point in the right direction. So site management process. So this describes how sites shall be managed to form the risks and present exposure. So this covers induction. So as part of good ground investigation, you induct the workforce on red site working, on the potential risks associated with the ground, and how you're going to mitigate it. This also describes the use of PPE and RPE and the training and application of what PPE and RPE you need to give to your workforce. Under the PPE regs, it's no point, you have to give the training, so it's no point in giving somebody a respirator. Just wear that. You have to show them how to wear it correctly, what filters are needed, why you need those filters to absorb and remove those contaminants from that airstream. Also, in this section, site management, it is covered. Pollution prevention is covered, and how you prevent cross contamination of your equipment and the ground. And areas off site from your activities. So, what do you need to consider during ground investigation to prevent that risk? So here's just an example, and this is taken from one of Socotec's operating procedures. We install aquifer protection, protect the groundwater where we have potential contamination in the deeper groundwater, deeper aquifer. And it's a process you've got to consider when working on contaminated sites, potential brownfield sites where you've got a potential migration pathway to impact groundwater. Those familiar drilling operations on this webinar will be familiar with the reduction of casing, telecopic casing, sealing it in and reducing down into with a smaller diameter so the migration of contamination above doesn't enter down the sides of your casing and into the groundwater beneath. Red site working practices. So in the guidance, it covers how to manage red sites, how you identify your samples, how you demarcate areas that's potentially at risk to the workforce. So all those things have to be considered. Um, where you have red site samples, they must be identified as red sites, so everybody's aware of the risk. And this is, as you can see here, some familiar labels that we use regularly within our business when working on red sites, identify the risks with those samples, so everybody's aware it's a red site. There's something significant about this. But in addition to that as well, we have a system in place where we have red site sample management plans, which is a pace which is paper which accompanies a sample from site all the way through to disposal. And it's a chain of custody which explains and identifies the risk from those samples, from the contaminants in those samples to whoever handles them at each stage of the sample life cycle. For example, once you on site, it identifies how they should be managed, because maybe contaminants have to be managed in a certain way, like volatile vapors. You can't have them in the back of your van if they're emanating vapors which can overcome you whilst driving. They need to be transported in open areas. It could also be how you're going to transport the samples. Do we need to consider the transport regulations, ADR, or any pressurized materials? Do they need warning labels on their vehicles for the materials that they're actually transporting? So it's red site working practice and ensuring people are aware of the risks from those samples at all stages. Managing health and safety in PPE. So this is generally how we manage the health and safety and pre-construction information, preparing for site investigations, ensuring that the PCI is reviewed, the site category is correct. We have our RAMs in place. We've identified all the hazards, and how we mitigate those hazards is, the last line of effect is our workers on the site with the PPE, RPE, and control measures like dust suppression, suppression fibers, etc., all that good stuff. So this is how we manage risk. So I've just mentioned some of these before at Soctech. These may be good examples for you to consider as well, or you maybe have some similar or even better practices. But these are what I consider as good practice to mitigate the risks. So recently we've developed minimum operating procedures for how a site should be categorized in accordance with the BDA guidance, the British Association guidance, and identifying each stage of what needs to be considered. We have a pre-construction checklist. So we identify, we know what pre-construction information has been given us. Have we got sufficient information to determine the correct site category? We've developed a process where we understand this, what are the risks that our workers are exposed to, what are the likely contaminants, what's the likelihood of those being present, are they significant, and what is the risk phrase associated with that? So how do we mitigate against that risk? And once we've understood all that information, gleaned that following this procedure, we can ensure the site category is as robust as possible. We've done all we can reasonably possible to understand it at that stage. So once you've understood the risks, RAMs are critical as any activity RAMs are. Identifying the hazards, who can be affected, the initial risk, severity and likelihood following that procedure, the initial risk and the residual risk once you've mitigated it through your mitigation. So this is red site sample management. One thing we've adopted, I've already explained this previously, is it accompanies the samples from site to disposal to ensure anybody handling those samples are aware of the risk at each stage and what mitigation has to be undertaken to deal with samples at each stage. Finally, once you've removed your red site samples from site, they've gone before they go to the lab, usually stored in a storage facility somewhere, either on site or actually back in their offices in ground investigation, usually a compound, or in a shelter in an enclosed space in the office. So this bit gives us some ways of dealing with how to deal with that material once you've removed it from site. So for example, here we have a procedure in Soctech of identifying the risk, quarantine or red site samples, keeping them separate, isolated away from all other samples in our stores, documenting them with the red site sample management plan, identifying them and securing them as well away from transport, forklift damage, anything which can inadvertently open them. So we contain them in plastic containers to make sure that they're all protected. And as well as that, there's a reclassification of sites process to consider. So you don't always have to. So there is a process to follow. For example, you see something on site, you find something on site has to be recharacterized. You may have a risk. You can always recharacterize it because there's always the likelihood of unforeseen contamination being present on your ground. So finally, how can we help our clients reduce risk during ground investigation? So we can support our clients through collaborative process, early contractor engagement. If you come to us earlier, we can help support you and guide you through what information is required through the pre-construction information stage. By doing so, we can support the information for health and safety, and it can be used to minimise construction risks during the ground investigation, to try and prevent delays later on in the programme. Internally, we've got a lot of expertise, particularly within ground investigation, well over 100 years within our technical teams and understanding of red site working and contaminated land. And as a business overall, we've been around a long time, 80 years of experience in GI and the processes involved. And being Soctech, we are multidisciplinary. We have various divisions where we can offer support from cradle to grave all the way across through the project. And our solutions are, we can provide initial site assessments, desk studies, planning support. Internally, we have a unique report library with 80-year legacy of ground investigation information from various sites across the country, which is unique from us given the duration of that period of all those investigations. And we can carry out bespoke reporting to your needs. So through the contract engagement discussion, we can come with a solution for you. So the aim, so this is a side where finished. The aim is we have a health and safe, we're carrying out the work safely, we're not impacting off-site receptors, our workforce are protected from the potential risk. Samples are there. So you can see the red samples. We have an exclusion zone. We're carrying out asbestos air monitoring downwind of our operations. We do things properly and as robust as possible, and our workforce go home safely and should live. We're not exposing them to them to live a long, fulfilled life. So, summary: ensure robust PCI in the planning stage is available. The site is categorised for the BDA process approach in their guidance based on the sufficient information. There's no guesses, no assumptions. The personnel who carry out the site work on red sites, particularly, are trained, competent. Project team are inducted and briefed and understand the risks and the procedures to manage and handle the materials and equipment during and after the operations. So that's it for me. That's enough on that approach on the potential risks and ways to do it. But if you have any questions, feel free to ask. Thanks very much for your time.